Yeah, okay. So what I did the other day was I went through the board here and I just moved the frets around until I found ratios that I thought I liked. These were the ratios that I personally liked. Keep in mind, I'm highly biased when I'm doing this because I've been listening to, Western music for a long, long time. More than most people because I do DJing on the weekends. So it's like my job to listen to music. For that reason, perhaps, I was probably a little more biased when it came to the ratios that I picked. Now, these were the ones that I picked. First of all, I thought that when the two string lengths were the same, the frequency I had started with was an E flat 313 hertz. And I thought when the two strings were in like unison, I thought that was pretty cool, so I put a 5 for that. Then as I shortened one of the lengths, I got the ratio here to be 1.166. And I thought that sounded pretty cool. Let's see if I can do an example of that just with a tone generator. I like this, I don't even know how to say that, Gießen. So I set mine to 313 hertz. That was 313. Now let's copy this, make another tone generator, and we'll listen to the ratio together. So what I'm supposed to do is multiply the 313 times 1.166. Comes out to 365. So let's put these side by side and listen to them side by side. All right, what'd you think? All right, well, that's a mathematical ratio there. 1.166. What is that as a fraction? If we get our calculator, I think it's 7 over 6. It is, see? 1.1666 is a mathematical ratio of fairly small integers. And that may have something to do with why I picked it out as something I liked. Now, if we plot them two together, we could go to Desmos and look at the waveform of what they look like when they're together. The way we make a wave is we do y equals sine of 2 pi times the frequency, which for me was 313, and then we put a letter t. So this is what's called my fundamental frequency here. Now let's plot the 365. Okay, so that's what we get there. And it's kind of interesting that if you just kind of squint, does it look like there's some kind of underlying structure there or some kind of repeating pattern? Yeah, I think so. There's kind of like a dense section here and a dense section there, and there's repetition in the cycles of this guy. Now, what if we add them two together? So I'll call this one y1, this can be y2. And I'll add y1 plus y2. That is the sum of those two waves. How's it look? Kind of cool, right? Cool picture. Nice rhythmic pattern to it. So yeah, that ended up being a significant ratio to me. Let's see what else I picked out. I picked out 1.2. Let's listen to that guy now. So I need 1.2 times 313. 376 was the next one that I picked out. So he's an important mathematical ratio too. He is 6/5, 1.2. Often called a minor third in Western music. Now, we can go through and add them two together as well. Probably going to get a pretty similar picture though. Okay, I also picked out 1.25. Let's do that one. 391. How's that sound? Called a major third in the Western scale. The ratio there would be 5/4. The first one that I picked out was 1/1. Then here we've got 7/6. I liked that one. I also liked 6/5. And this one's 5/4 actually. So the decimal equivalents of these is 1, 1.166 repeating. This is 1.2, 1.25. The next one I picked out is similar to 4/3, 1.333 repeating. And a lot of you guys picked out that one as well. Let's hear what he sounds like. 417. Okay. If we were to go to Desmos and plot that guy, let's see what he looks like, just out of curiosity. Okay, do you see some kind of repetition? It's a little tough to tell when they're just side by side like that, so let's add them together. Okay, so pretty rhythmic pattern. This has something to do with why the ear likes it, and it doesn't like other things. Yeah, another one that's really common is 1.5. That would be 3/2. This one I gave a 9. I really like the sound of that. And in fact, in Western music, a ratio of 1.5 is known as a perfect fifth, they call it. Yeah, 4/3, they call it perfect fourth. Interesting. That's this one here. I really liked those ratios, but like I said, I was a little biased. Now you guys, when you did this, I didn't tell you you had to stay between 1 and 2. I just left it open. I said just find any two notes that you like the sound of them together. Yeah, now a lot of you guys picked, I have your results right here on my Excel sheet. Okay, those were my results right here. Now I plotted both my personal favorites along with the mathematical ratios. So there's certain mathematical ratios that I wanted you guys to plot. This is pretty cool right here because it shows how closely my preferences align with the mathematical ratios. Now I'm going to draw on that picture here for just a minute. I picked these ratios in blue. The blue was my choice. The orange was the mathematical ratio. Let's start over here on the right. This is a 2-to-1 ratio. And I picked that as something I liked. Now, when you guys did it, I was surprised to see that I don't think many people picked that. A 2-to-1 ratio in Western music is known as an octave, where I started with a certain note down here. Let's just say, hypothetically, so that we were all on the same page, let's just imagine we started with like C4. Then an octave would be double that in frequency, so it would be C5. This would be a 1-to-1 ratio over here. Now, not everybody picked that, like I was saying. I was a little surprised by that. If we go back to the Excel file, this was you guys' choices. And interestingly, there wasn't anybody who picked the 2-to-1 ratio there. I was a little surprised by that. But there are places where your guys' choices and mine lined up. For example, we all liked the ratio of 1.25 approximately. Okay, so that would be a major third in Western music. A lot of people like that. Let's see. You also picked something like a perfect fourth. It looks like you got around 1.33. There were several responses in that range. And the orange shows that that is a mathematical ratio as well. 4/3 is that one. This one's going to be 3/2. Over here, this would be the 5/4. So this guy is a perfect fifth, it's called. This is a perfect fourth. This one over here is called the major third. Now, why are they calling it third, fourth, and fifth? It's because of the piano keys. So let's just say hypothetically that I start on a C. If you start on a C, well, first of all, an octave would be 1, 2, 3, 4, 5, 6, 7 keys. But this guy here, the G, would be the fifth key away from C. That's why they call it a perfect fifth. This guy here would be a perfect fourth, and they call this a major third. But also, this guy would be called a minor third. All right, he's 6/5. And then one other ratio that I liked personally was 7/6. All right, so hopefully you guys came up with similar results. Now, just out of curiosity, what could we do with the notes that you guys chose that were beyond 2? Like, could we figure out what notes those are? Well, now, hopefully with you guys' like understanding of the keyboard and the frequencies that go along with them, hopefully you could change them and figure out what notes they are. Okay, so like take these guys for example. These are all a bunch of ratios you picked that were beyond 2. So these are more than an octave above the range that I was just focusing on just now. So let's see if we can quickly like figure out what ratios they would correspond to that would be within the range that we're examining, right? Okay, so let's paste that. What if I slide this graph over? So I take your range of like 2. So here's a 2, a ratio of 2. And then here's a ratio of 3. Okay, what if I stretch this and make it line up with these notes? It turns out that is close to what I need, but not exactly. What I need to make this truly be equivalent is I got to go all the way from 2 to 4. Because the difference between 2 and 4 is an octave. So let me start at 2. And I'm going to go all the way to 4 here. And I'm going to paste that underneath my drawing. So now we got 2 on the left. And you got actually 3. It's hard to see, but 3 is in the middle right here. And this would actually be a 4. Now, one of the things you guys liked, or some group liked it, was you guys liked 3.02. So what note is that exactly? You liked 3.02 times the original frequency. So that's going to be a G. All right, so C goes on the left side. This will be C5, and this is going to be C6. So what's in the middle? A G. And so it's just interesting that you could do that. And look at this. Somebody liked a ratio here of, well, that's going to be an E. It would be E5 approximately.